Hey guys, so in this video we are going to discuss the inverse of a matrix or matrix inverse. So before we proceed, let me just start with this equation here. Let's say we have a linear equation 3x equal to 9. Now, how do you solve for the value of x here? So maybe yung gagawin nyo is you will simply divide both sides of our equation here by 3. So that will cancel out the 3 here in the left side, and then we are left with x equal to 9 over 3. So that is equal to 3. Or, similarly, pwede din natin gawin is we can multiply both sides of our equation here by the inverse of 3 or yung reciprocal niya, which is equal to 1/3. So by doing this, we will obtain a similar solution. Ibig sabihin, dividing our whole equation by 3 or multiplying it by 1/3 is basically the same lang. Same lang naman yung sagot na makukuha natin. So let's have another equation here. Let's say 2/3 of x equal to 10. Again, yung pwede nyong gawin dito is you can divide both sides of our equation here by 2/3, or similarly, what we can do is we can multiply both sides of our equation here by the reciprocal or the inverse of 2/3, which is equal to 3/2, and that will give us the value of our unknown x here. So as you can see, if we multiply a number here by its inverse or its reciprocal, yung magiging sagot niya is equal to 1. So now let us try to apply this idea for matrices. So let's say we have this matrix equation here, matrix A times matrix X equal to matrix C. So let's say that the value of matrix A and matrix C here is given. So bali hahanapin natin yung value ng matrix X natin. Parang similar siya doon sa dalawang linear equations natin kanina. So how do we solve for the value of our matrix X here? Baka gagawin nyo is you will divide both sides of our equation here by matrix A. Pero hindi ito pwede because for matrices, there is no such thing as division. Okay? So hindi ka pwedeng mag-divide ng matrices. So instead of dividing, what we can do is similar doon sa ginawa natin kanina sa linear equation natin. We will multiply both sides of our equation here by the inverse of matrix A. So the inverse of A will be denoted by A raised to -1 here. So similar doon sa linear equation natin kanina, if we multiply a matrix by its inverse, yung makukuha natin is an identity matrix. Recall that an identity matrix has the same property as unity or yung number 1, where if we multiply any matrix by an identity matrix, the product will be the matrix itself. So now we are left with matrix X on the left side of our equation here, and then this will be equal to the product of the inverse of A times the matrix C. But remember that matrix multiplication is not commutative. So therefore, the inverse of A times matrix C is not equal to matrix C multiplied by the inverse of matrix A. To maintain equality, we need to multiply the inverse of our matrix here at the same place. So sa left side ng equation natin, doon natin siya nilagay sa leftmost side of the left side of our equation. And then similarly, we will multiply the inverse of A doon sa leftmost ng right side naman ng equation natin. Okay, so hopefully you have understood the concept behind the inverse of a matrix. So now let us proceed to how we determine or solve the inverse of a matrix. So for example, we have matrix A here, and then we have its inverse. Again, the product of these two is equal to the identity matrix. So the inverse can be computed in a column by column fashion. So the equation above can be rewritten as 4 separate systems of equations, where each column of our matrix X here is the unknown, And then, yung constant naman natin dito sa right side corresponds to the column in our identity matrix. So, for our first system of equation here, yung unknowns natin will correspond to the first column of our inverse matrix. And then, yung constant naman natin dito will correspond to the first column of our identity matrix. And then, similarly, for our second system of linear equation, same case pa rin. So, solving these four systems of equations gives the four columns of the unknown matrix inverse. As you can observe in this system of equations, the coefficient matrix is the same for all four systems. Yung nag-iba lang is yung right-hand side constants natin. Okay, so ibig sabihin, yung LU decomposition method natin will be very useful for calculating these types of equations. So again, as we have discussed on our previous video, yung LU decomposition will be very useful pagdating doon sa sets of system of linear equations where pare-pareha yung value ng coefficient matrix natin pero different yung values ng constant matrix natin. Okay, so let us take this matrix here. So yung gagawin natin is hahanapin natin yung inverse ng matrix na to. So again, the inverse of this matrix can be found by solving these three systems of equation. So in this case, tatlo lang kasi this is a 3x3 matrix lang naman. So let us put x here as the value of our inverse matrix. So again, itong constants natin dito is from a 3x3 identity matrix. So yung first is sa first column, yung second naman is sa second column, and then yung sa third set natin is from the third column of our identity matrix. We will use LU decomposition in order to solve for the inverse of this matrix. Recall na yung gagawin natin first is to decompose our coefficient matrix. So from our previous video, this will be the value of our lower and upper triangular matrix. So ito yung decomposition ng coefficient matrix natin. Again, you can review the previous video kung paano natin to kinuha. So let us take our first set of linear equations here. Again, the second half of our LU decomposition will be the substitution phase. So first, using LDB, so we will solve for the value of our intermediate matrix D using forward substitution. Therefore, we will have this value for our intermediate matrix. And then, using this value for our back substitution phase, so yung UXD naman, where we solve for the value of our unknown matrix X using back substitution. So after performing back substitution, we now have these values for our X, which corresponds to the first column of our inverse matrix. So next, hanapin naman natin yung second column ng identity matrix natin using this second set of equations. Again, yung kagandahan sa LU decomposition method is hindi na natin uulitin yung decomposition na part. Okay, so dediretso na tayo doon sa substitution phase. So here in our forward substitution, papalitan lang natin yung laman ng matrix B natin. And then we will solve for the new value of our intermediate matrix D. After that, we will simply use these new values here in our back substitution phase in order to solve our unknown matrix X. So these values, etong values ng matrix X natin dito, will correspond to the second column of our inverse matrix. And then finally, for our third column, papalitan naman natin yung value ng constant matrix B natin dito. So ilalagay natin yung third column ng identity matrix. And then by forward substitution, we will obtain the new values of our intermediate matrix D. And then using these values, dito naman sa back substitution natin, we will obtain the values of our unknown matrix X, which corresponds to the third column of our inverse matrix. So this is now the value of our inverse matrix A. Okay. So ngayon, pwede din naman natin i-verify kung tama ba itong nakuha nating sagot by simply multiplying matrix A by its inverse, yung nakuha natin, and then checking if the result is an identity matrix. So pag identity matrix yung lumabas dito na product, ibig sabihin, tama itong nakuha natin na sagot. Okay, so this is only one of the many methods na pwede nyong gamitin to solve for the inverse of a matrix. Pero yung kagandahan lang sa method na to is madali lang siyang i-apply kahit anong size ng matrix. So kahit 4x4 matrix or 5x5 matrix pa yan, madali lang kunin yung inverse niya using LU decomposition. Okay, that's it. Thank you for watching. See you on the next video.